Hello, everybody. So this is the last day of lecture for the class. Remember, everything is due by Sunday, 11:59 p.m. That was the date for the end of the class that was set years ago. That I don't waver on those, the final deadline. I wake up early in the mornings, so then Monday morning I wake up and finish up any grading, and I usually have grades submitted by 7 or 7:30. Long before most computer people wake up. So make sure you get everything to me before 11:59 p.m. Got a couple things to talk about. There's one, it's a little spiel I give in every single class that I teach and realize that I'm giving it again. Oh, some of y'all have heard it before. Ergonomic stuff. We got all the way to the end without giving that little spiel. Start with that. Then I wanted to look at something related to markup languages. It does show up on web pages, very, very useful. But it's also a common thing for software developers. That's going to be scalable vector graphics. The standard format for two-dimensional vector graphics, that's where instead of storing like pixel data, that's what you probably think of with a bitmap. That's not the only one, but we go pixel by pixel and just define what each pixel is going to be, right? Like this one's red, got some red pixels over here, some green pixels down here. And that's what a lot of people think of, but that's not the only way to store pictures. JPEGs are actually stored as a wave, cosine function. Math gets a little complicated and it gets hard to talk about, but if you looked at a picture of it, it looks like a sound wave. That's not a good analogy though, because a sound wave actually is a representation of that wave for the sound. And the wave that's storing that in a JPEG is just a purely mathematical model. It does not store the light that represented in that image. In part, it only has red, green, and blue, and there's a whole lot of light missing from that. But different things, and one of the best ones to use goes back to like math class. We have our XY plotting area, and instead of remembering like which pixels are which color and setting all that up, we store it as an equation. So we wanted like a circle, it would be stored as an equation up there. If we wanted a tree, that's like a circle with a line underneath. Try to write this sideways, y equals mx plus b. That does not look like an x. I guess the x doesn't turn. But we have the equation of a line, the equation of a circle, and the positions there, along with some color data and stuff. And when we save it as a function like that, I guess we need to transfer the circle into function form, which is actually two half circles. But we have it as a math equation, so the computer recalculates that every time. So it doesn't matter if we look at it on a 72-inch screen or a 7-inch mobile phone. We don't lose clarity as we scale up or down because there's nothing to stretch out. We recalculate every single time. So a really good way to do graphics. If you ever make some graphic software, I believe everybody in here is doing software development, so maybe one day in the future you're going to actually make some graphic software. You probably want to work with vector graphics, and then you can scale up and down, zoom in and out, and all that nice stuff. And then at the end, when the picture's finished, then you convert it to a PNG or a JPEG or something big size. I want to look at that, and it's markup languages. It's related to what we're looking at. Depending on how time goes, there's more stuff we can cover. Maybe the canvas element. It fits with the graphics skill. Well, it'll show scale for vector graphics, but there's an HTML element that we can draw on with code, or we can load images in it. So if you want to make a game engine, whenever I make a game engine that's going to be web based, I base it off the HTML canvas element. It's just a drawing surface, and it accepts WebGL, which is pretty much the standard standard library for 3D graphics. But the standard is OpenGL. So all of the biggest game engines were built off the same library. All the biggest ones and most of the smallest ones were built off this library called OpenGL that has been adapted to just about every language, every programming language we have. And there's a web-based version as well. This can modified slightly for transmission across the network, or improve transmission across the network instead of just from the CPU to the screen when we're running local things. So we can run that, or it's just a blank drawing. An HTML element that's just a blank drawing surface and we draw on it with Java code. Or load images onto it and move them around with Java code. So a very useful one if time allows. If we were, so I don't want to, like the other day, I want to keep the lecture kind of short. This is the last day of class. We covered all our main learning objectives, but it's an active subject. So instead of a final exam, we have a final project. So I'm sure y'all could find some stuff to do on your final project with the extra lecture time per day. But a few things to cover. Right before the recording started, I was talking about some stuff coming up soon and thought, well, this will go good on the recording. I should cover this because this is another software development thing. It's a dynamic field, it changes. There's always new technology coming out. And most of the big companies have major conferences once or twice a year where they're presenting new technology and stuff. Apple's has changed. Apple's has become a big commercial. They announced the technology to developers and IT support people a few weeks before they announced it to the general public where it's a commercial. So their conference is different. It just became a 3-day commercial, but that's Apple. A lot of other companies still doing. There's some two really big ones coming up very soon. One of the schedules was just announced about 2 hours ago. That's why it was on my mind today. I was talking about that before class and thought, oh, I should share this. And the conferences like that, they can be a little expensive at times, but it's one of those things that usually your boss is going to pay for. The company you work for is going to pay for because it's different labels, continued education, professional development, personal development. One of those titles where the company pays for you to, in the case of the one that was just announced a couple hours ago, fly out to San Francisco and take part in Meta's game developer conference. It's March 20th through 24th. Oddly enough, there are no virtual options of attendance. All you can do is attend in San Francisco, so it's lifetime attendance only. But surely this stuff will be, there'll be videos available afterwards. Surely they're going to record some of them and put them out there. Some interesting things, and as soon as I find out, like one of them is it's an entire day long, 8-hour session about Web3. It seems odd that there's no virtual option for that. You have to be at a really nice hotel in San Francisco to attend the session, but maybe they've just been losing money on the tickets for that, right? They rent out a big hotel, and then if everybody attends through Zoom, the company's not a lot of money for the hotel they're in. Because these are worldwide conferences. So that one's coming up, and when I find, our class ends today, right? Some of y'all I will see in a couple after spring break, and I will have some information about that. Yeah, me in class after spring break, we'll probably hop in and look at a couple, because this other one is one of the biggest ones in the world. NVIDIA's GTC conference. We know NVIDIA because of the graphics conference, but that's not all they do. NVIDIA kind of has their hands in everything. They have lots and lots of hardware. They make lots and lots of hardware, and then they need to make sure developers, pathway you all are on, know what to do with that software. What software to write to make use of their hardware. So they have this big conference twice a year. It's not exactly split every 6 months. The last one was in September. Kind of varies, but twice a year they have their GTC conference. And theirs is huge. Like in America, it's usually someplace nice like Santa Barbara or Miami, maybe some in New York, but it's spread out across the world. So There's workshops and training. These are the ones that cost money. So this is like the personal development. Pass this on to your bosses, but one that really caught my eye is nvidia.com/GTC if you want to look into it. Close the ad there. Should I have not close that? Maybe I should have read to see if there was a button I needed to click. The screen grayed out when I closed it. That was odd. They have this conference on building conversational AI applications. That's a big deal coming up. So it's an 8-hour session. Yeah, 12 to 8 Eastern time, but it's happening in California somewhere. Not sure where it's at in California this time, but $149 to attend. Those are common things. You go in there and you learn how to make one of those. In this particular one, in an 8-hour session, you're on make a chatbot from scratch. So training sessions like that, but then there's also just lots and lots of sessions. The keynote, which the NVIDIA keynote always has some of the session catalog, that's what I want. Always has some of the best updates on technology for the year. And not just the current technology, but where technology is heading, because those are the people that know it. And in the one last fall, when they were announcing their 5-year plans, every single one of their 5-year plans involved CPUs, GPUs, and DPUs, data processing units. So they have plans for hardware being ready to for a lot of optimization as things move through it. So that's going to affect you all the software developers. You want to keep up to date on some of these things. The keynote will be interesting. That's next Tuesday, or sorry, the Tuesday after spring break. I just stopped counting last week or next week. So yeah, spring break, nothing's happening there. I'll skip right over that date, but 2 weeks from now, I guess. All sorts of fireside chats and different things. Virtual conference, there's a lot of overlap between these two things. So actually, that might be why there's no virtual presence, because they have theirs, but then the virtual, they're just going to transmit it through NVIDIA's conference, because that's a much bigger one. If I scroll down through here, much bigger. There's one, I think it's near the top. It was the other day. Yeah, so it's worldwide. NVIDIA is a huge company. We know the graphics cards, but they have their hands in everything. So they had to have stopped the translation on that. Somebody hard coded, don't translate this to indicate that whatever language that is, like if you don't speak that language, nobody at that session will speak your language either. So it's a big worldwide thing, one of the biggest around. But you want to stay up to date on the field. We have an assignment related to that, the new technology report. But those are 2 big conferences that will have a lot of interesting technology coming up soon. GDC does not, the Meta Game Developer Conference does not have does not have a virtual presence that I could see, but the schedule just came out an hour and a half ago. So it's I definitely didn't have time to look at every page on their site. I'm gonna look through there, but those aren't the only conferences. Make sure you look around for those things and stay up to date in the field. We are in a very dynamic field, and especially NVIDIA's, they got their hardware down pat, but they need to make sure the developers know what to do with their hardware. So they are the people that can tell you what to write specifically for the machines they're developing. So you want to keep an eye on those. So now the first thing I kind of want to talk about today, usually I talk about it earlier in the semester, but I try to talk about it in every single class that I teach. I'll use these. If you're in this classroom, you're planning on a working career sitting at a computer, right? 40 hours a week sitting at a computer is very, very bad for the human body. The human body is a very dynamic thing. Some of y'all have probably experienced that with like exercise before, right? Like I need to get in shape to start exercising. the human body is really, really, really good at doing activity. Like rowing machine uses most, in the gym, typical gym, that's the machine that's going to use the most muscles in your body. And if you go as hard as you can on a rowing machine for like 20 minutes, you'll only burn about 30 calories more than you would have sitting on the couch doing nothing. The human body is really, really good at doing that. So sitting at a desk is kind of a terrible thing to do to our bodies. Example I often use is compare an IT career with construction workers. They're going to have a lot more little injuries along the way. Right? Fingers smashed, pinches, little cuts. But by the time we reach retirement age, they're going to be in much, much better shape than those of us that sit at a desk for 40 hours a week. It's so unnatural, those big square things. We'll talk about that in a second. Let's start with the keyboard. This big flat thing. This is not a good shape for the human body to move. If I go to use this, which let's see if I turn on my camera here. If I go to use this, I have to force my hand into a position. At the bare minimum, you want to try to do it like piano lessons. If anybody ever had piano lessons, you don't want to swipe down on keys. You want to bend at your knuckle and try as much as you can to push straight downward. It makes a difference. Hand has to be held at a weird angle. The way we normally rest our arm on it and use a keyboard causes damage. This tube that runs through your arm and holds all of the nerves that go from your hand up to your brain, they run through a tube called carpal tunnel. And desk jobs are one that's really bad, especially sitting at a keyboard, basic keyboards, for eventually developing carpal tunnel syndrome. If that tube that holds all the nerves gets damaged, my understanding is your brain just constantly receives a pain signal. So your hand doesn't really hurt. It's just somewhere on the way between your hand and your body, the nerves all decide to tell your brain that your hand is in intense pain all the time. It sounds very unpleasant from the people I know that have done it. So little things like that if you're in this class, I always like to take a moment and talk about the things to avoid some of those that we can do to avoid that. One of the big problems is on a flat keyboard. I hold my hands out like I'm going to type on a keyboard. That shape should look familiar for those seeing on the camera. But if I relax my hands, they do this. This relaxed position, that forcing it into the other position is what damages that carpal tunnel and eventually leads to carpal tunnel syndrome, which is, by my understanding, just a constant. Your nerves just constantly tell your brain that your hand hurts, even when it doesn't. So there's little things we can do to avoid that, and in particular, that relaxed position. Just holding my arms out relaxed. My hands want to do this. So that's a problem with this keyboard, but they do make keyboards that adapt to that. Let's look at a keyboard. I also want to look at this picture. Ergonomics Wikipedia, they've had this picture on here for like 20 years. Some of these things are a little out of date, but that might be at least a good place to start looking at it. There's a lady in the chair. So, it's behind the Zoom thumbnails on the TV's in here. Let me put that out of the way. So a couple things that are right and a couple things that are wrong in this picture. It's kind of out of date. But that angle looking at the screen, you want to look straight at your screen. Adjust your chair height so you're looking straight at it. A flexible chair makes a big difference. The angle is coming in at hers is a bad angle. We really should be coming. It's better if our arms come down to the keyboard. Yes.
I just wanted to say a personal recommendation for ergonomic keyboard is the Lenovo Wave.
I think so.
It's an older keyboard, but it's really, really nice. And you can get one for like, I got mine at Goodwill for $5.
I think that's one of, waves have been popular for a minute. That's one of the ones I was just gonna do a search and look at some pictures here. But yeah, if you're heading into this field, you're gonna make, some of these prices might seem expensive as a student. But when you're making really good software developer money, it's not gonna be that. It's kind of the idea of getting the nice tools. You know you're gonna be using a keyboard a lot. So it's probably better to get one that doesn't hurt your hand versus Lenovo. I don't say Lenovo.
Lots of tech services.
Oh, Lenovo makes a really nice one too. But Logitech. Oh, this like this?
It's kind of like that. That looks like a rotated design.
Okay. Oh, there's one at a good angle. Yeah, so it's like this. But any of them like that, and notice that what I mentioned with the relaxed position hand, relax your hand, it goes to that position. So a keyboard that's in that position will do a lot less damage to your body over time. The split keyboards are really nice too. You can put those in either spot.
There's a wave right there. If you scroll up there,
Which one?
that one, the end zone, that
Ah,
great keyboard.
yes.
It's old, but it's great.
Yeah, or you can see there they're not, the keys aren't in a grid, a square grid. That makes a big difference. This something like that takes it to the extreme. Your hands are completely separated. Or the multi-part keyboards, that'll play into something we're gonna look at in a moment as well. Where you just have the two halves of the keyboard and you set them wherever is best for each hand. We have to look. There are also these. So a big difference. Anybody doesn't know the story of the order that our keys go in back in when typewriters were first invented. A lot of the common letters are right next to each other in the alphabet. So when it was mechanical devices, the levers holding the letters would jam against each other. So it's organized in a way that the letters next to each other are the least likely combinations. Or if two letters are most often next to each other, Q and U, I guess, are the example because they're always next to each other, right next to each other in English. They're almost as far apart as we can get letters. It's way across the keyboard, so it spreads it out so that the levers wouldn't jam on each other. And after World War II, when they created headbacks, they adapted to that. They just adapted a keyboard or a typewriter, had an electrical signal to it, and just kept that layout. We still have that today. It's a strange order. It just kind of came out over time. Nobody spent a whole lot of time for it. We just like, oh, we need 100 buttons on there. So they put 100 buttons on a square plate. But now the time has been spent on it. There's also these, the radio keyboard. So this one right here, the biggest difference with this style is this was not designed by engineers. Well, there was engineers on the team, but this is the one designed by orthopedic doctors. So the world's experts in the human hand say that is the best shape for our hands to use. Obviously, you'd have to learn to retype completely to use that. But if you're doing it 40 hours a week, right, and you're going to use that keyboard, it's not going to take long to learn to retype. You zoom in on it, it's still oh yeah, the order is, you'll see the order of the letters is completely different and everything. But that's the one that actual medical experts in the human hand sat down and figured out is the best shape for the human hand to work with. That's a little bit extreme. Those other ones, the ergonomic, these make a big difference. There's lots of different types. It's showing expensive ones up here at the top. You can try out some different ones, like 40 bucks, and that's one that curves up a little, not as extreme as like this one with the two halves and has that full, it's not a smooth curve up, it's like a broken bowl curve. or the ones that just have that smooth ramp up in the middle, they make a big difference. The split keyboards are really nice for something we're gonna look at in a moment. It's not the only piece of equipment we use. Let me stop screen share and turn this video back on. This mouse reach camera. Oh, this one will reach over here. So this one, but something you'll notice very, very quickly in this in the video here, or those in the classroom, is I cannot hold this thing and use it in the same way. To hold it up with one hand, I can't use it that way because one of my fingers has to kind of at least curl under a little bit to hold on to it. Then we rest our hand on it and we end up with a lot of those same things. This shape was not very well planned out to begin with. Does anybody know the story of that shape? Let me pull up the original mouse. Turn on the camera, share the screen. So in 1968, or whenever he was making it, it probably stretched out for a while, the engineer just needed a place to keep it. He had the idea, he had all the hardware worked out. And on his box, or on his desk, was a little wooden box that held paper clips. So it was the perfect size to hold the hardware that he had in mind to make this computer control device. He never intended for that to be used, for that to become the perfect permanent shape. That was his paper clip holder. It's like, oh, this is the right size. And he started putting things in it. But we never really left that box shape. So it's not the best one for human hand to work with. That one belongs to the Smithsonian now, and it does tour all over the world because the first mouse is a big deal in our modern world, as you're all probably imagine. So it belongs to the Smithsonian, but it's constantly on tour. But just like the keyboards, there are some better shapes we can use. Vertical mouse. Does anybody ever use one of those? Oh, we can see it really nicely in this first picture right here. It's back to that relaxed position of the hand. If we relax our hand, it goes right in there. You'll notice that that one can also be held in the same position you actually use it in. So it's a lot like a regular mouse. You're just turning it sideways or turning it off to some angle that's better to use. So little things like that. A good keyboard and a good mouse will make a big difference if you're planning on an entire working career sitting at a computer. And those aren't so bad. $20, 160 just on the ones at the top. That's about the normal range. That's about the range we would pay for a normal mouse, right? I guess the ones here in the classroom, those are probably like $10. Most of us wouldn't buy the $10 one unless we were really, really short on funds. We bump up to at least the $15 one at Big Lots or something. But by using the right tools for the job, the ones that somebody actually sat down and thought about, that it's not going to hurt your hand. Trackball mouse are also much better for the hand. That's the one where the ball moves. The mouse stays stationary and you just move it with your thumb. Joints can wear out, but as far as muscles go, there are two muscles on the human body, or really there's four because it's symmetry, but there are two muscles on the human body that will never get exhausted: our thumbs and our hips. Our joints wear out. Lots and lots of senior citizens have to have their hips replaced. But those muscles that control those are two of our muscles that our bodies will take energy away from our brain in order to keep those muscles moving. So if your mouse is stationary and you're only moving your thumb, it's another one that's good for the body. You're not dragging your mouse around with that unnatural position on your hand. They are slower. Artists really like them. CAD designers, some graphics artists, because you have to move that ball a long way sometimes. But you get really, really good control and your mouse doesn't change. So the really nice thing for art is sometimes if you're not careful with your mouse, up and down and left and right change a little from where it was a few seconds ago. and it'll throw your lines off. But those can also be beneficial. They're oftentimes a little bit slower. Starting to see these more as well. That's another natural position much more natural position for the human hand, where the buttons are in the inside. I guess it's like the VR controllers. Those are great. Those are very well designed for human hands, the way they're set up. But if you just glance at them, it looks like the buttons are in strange places and they're lopsided and off balance. But the right equipment makes a big difference. But not just those little things, because we're going to use those things sitting at a desk. I know some of y'all probably heard me give this spiel before, but for those who haven't heard me talk about it, do you know what the best position for a human to work in is, right, as far as desk work? It's not a big square rectangle. Right? There's nothing natural about that shape. If there's any big perfect rectangles in the natural world, they're oddities, and we'll see signs all over the interstate as a tourist trap or something. It's like a really weird, strange rectangle just showed up in nature. Does anybody know what the best shape is to work in? You haven't seen me give this little spiel before. So it's what's known as zero gravity position. This shape, this position. There's also something called zero gravity chairs that they put in cars, but like that first picture there is zero gravity position. So I have no idea what the one in cars is. You would not drive a car from that position. They look a little uncomfortable. It takes some getting used to. Though some of these are really nice. Like that one probably is all motorized. So it's like a normal chair when you get in, it just rolls back. But if you had a nice zero gravity position, those split keyboards and a vertical mouse, it'll do a lot less damage to your body. Oh, or the Scorpion desk, those are fully automated. All that stuff there folds up into the back of the chair. You sit down in the chair and hit a button. She's sitting upright, but it does roll back to like a zero gravity position. But not cheap, but you look really cool using one of those desks too. And there's just a chair and you sit down and hit a button and all that stuff comes out and it rolls back. They do make some chairs. Yeah, so that you can also get just a chair. Doesn't have to be the $20,000 desk, but just look for chairs. They're considerably cheaper, and remember, it would be a business expense. So if you're making 120 grand a year as a software developer, having a really expensive desk as an itemized deduction can help with taxes over the course of decades. Well, they're still showing workstations when I click chair. Let me just search chair. Okay, yeah, so some that are more like normal chairs, they just go all the way back to the zero gravity position. And you'll notice that it's not like laid down flat. Right? It's important that the wave shape for your body curves like that. It's sort of the best shape for human body to stay in for a long period of time. Things to think about, some of those chairs would be a whole lot cheaper than the things, but yeah, it would be alarming. Like that's a professional model. If you sit in a chair and it rolled back that far, her job is to sit there and smile. There's probably a lot of panic going on in her mind right when that picture is taken. Definitely probably feels like you're falling the first time or two, but it makes a difference. If you're in this class, then you're planning on spending a working career at a computer. So those things like that will make a big difference over time. I always like to give that spiel in every class I teach. Every class I teach involves people that are going to spend like 20 to 40 years at a desk, which is not good for the human body. Human body is a dynamic thing. It's at its best when it's moving. And the stationary, unnatural positions will do damage over time. Quite a bit of damage. Let's see, the next thing I wanted to look at had to do with graphics. It relates to markup languages. We've been looking at markup languages here. This semester, that's what one of the main focuses of the class was. But this is one that's you'll see elsewhere across the field. As mentioned earlier, this was after class, right? I didn't start writing that before class, did I? I remember I was talking before class, but instead of just storing pixel data or something more complicated, that'd be a bitmap or a JPEG. We actually have this something that looks like a sound wave. If we looked at a picture at it, it's a complex mathematical representation storing it. A ping, we have a bunch of we separate that, but it's still kind of, we separate it into several different shapes, and then another shape with some holes cut in it where those would go into. It gets a little complicated with that, but usually we think about the bitmap thing, pixel by pixel data, saying what color it is. But it can be a lot better if we just store the mathematical equation that describes an image. Vector graphics, and in particular for 2 dimensions. In the machine, 2 dimensions and 3-dimensional vector graphics look the same as they pass through the CPU. But in the text file where we as programmers work with them, they look very, very different. So the most common way to deal with 2-dimensional vector graphics is to use scalable vector graphics, which is a markup language like we've been looking at this semester. So I'm going to look at some of those. And it embeds right in, goes right in HTML. So I'm going to do that. New folder for images. Image stuff, that sounds like a good name for it. And I'll just make it index.html. So still an HTML file, like we've been seeing. I'll put some random title on here. That part's not necessarily important for what we're going to look at. But we can put a particular element in here to deal with these vector graphics and kind of introduce them. So we have this SVG tag. And in between them, we can add certain shapes. A whole lot like the shapes that we saw before. So the first thing we need is probably a size for this. Okay. We're going to draw a picture here, so we need some sort of size information for it. I probably could have guessed that one. Let's say 300 pixels by a height of 300 pixels. We'll make a 300 by 300 square that we can draw on. And then we use this markup language to indicate what we're drawing. Well, we saw the basic shapes the other day. Circle, I'll draw it right here. I have my pen out. Instead of stopping the screen share and putting it on the board. I drew the version of look like an apple, like we see in algebra class earlier, more of what's going on internally. But as far as programming, the way we handle vector graphics in our text files is different than how the CPU handles text graphics. The CPU does something more like this, like I drew on the board earlier. But we don't want to sit and type like it's a math class, right? We don't want to type all those geometry formulas. The computer already knows the geometry formulas. We want to be able to just say it's a circle, like we have a circle. And We saw the other day that to describe a circle, we need 3 numbers. So we need to know where the center of that circle is and what the radius is. So that's the information we need to define a circle. So we can put that right in this markup file. What was that? We have several parameters built in here. So CX, the center position. So maybe 28. And CY, the center Y value. The two XY coordinates of the center. So we need whoever created the tag went ahead and included the C for center X and center Y. 28, 33, and then we can do some other things. So stroke will be the color we draw it in. Maybe blue. Stroke width. I'm going to leave stroke width off. We'll come back and add a couple more. Yeah, that's probably good. Let's look at that and then look at a couple more parameters. I don't know what to do. Go in here and actually open that file. So don't see anything yet. Should be something there. And that is that next parameter I wanted to add in there. Stroke width equals maybe 3. These are all in pixels. So now when I save that, reload that, why is that not doing anything? We get an error message somewhere. No error message. But does anybody notice something I might have forgot? I said it just a moment ago. What all do we need to define a circle? We need 3 numbers, right? I skipped or forgot one. Forgot the radius, only gave it 2 numbers. So we just assumed the radius of the circle was 0. Equals 12. 12 pixels, that sounds like a good size for a circle. And we get that circle drawn. The background looks kind of odd. Take a stroke width. So then draw a blue circle. Maybe to zoom in. Close that so I can zoom in. Here. Zoom in as far as I can. And notice we don't get any pixelation zoomed all the way in. At every level along the way, it recalculated. So that's why you would often use these. By default, it's 1 pixel, which at our normal zoom size, it's hard to see. So stroke width, make it a little bit thicker so we can see that blue circle. And by default, it seemed to just fill it in with fill equals, well, it filled it with black, but that's probably not gonna be good. We have a white background, so maybe fill it in with white, and then we'd see the circle instead of a ball. A ball is a solid shape, circle is just the outline. Or any color, maybe yellow. You would want to use a named color or hexadecimal. So some of those other ones, that we have in CSS, the RGB, HSV, all of that, those are for CSS. And we pretty much always have our hexadecimal colors. So you want to use either hexadecimal color or a name color for these. That's why you're open. Put the wrong thing somewhere. We have our basic shapes like we saw before. Well, the other day. It's also rectangle. And grab a pen again. Like we saw the other day, in order to define a rectangle, we need two sets of points. X, Y, and I'll call these WH. The second set varies depending on our programming language. Sometimes it's another XY coordinates as far as the space we're drawing them on. And then the computer will find the difference between them. And other times we give the first point and then how wide and how tall it is. That's why I went with W and H. But we do need 2 points in order to define rectangle, and we have the same thing here. Rectangle, oops, sorry, rect. That's almost always abbreviated to no matter where we're typing. Width is maybe the original one's not it. The example I was looking at didn't put the originals in there. I think it's just XY. X is, I'll put it kind of overlapping the circle. So 37, Y is 41, that way it kind of overlaps the circle. And then width, so SVG, it does want the width and the height. How many pixels wide is it? How tall is it? Maybe 120 pixels wide. Height equals 44 pixels. And then we can, set an outline the same way. So stroke equals green. Stroke width. 2 pixels this time, and fill equals red. Okay, so it'll look kind of Christmassy. Okay. Well, that didn't overlap as much as I thought it was going to. I guess I could have done the math a little bit better. I came over and down far enough that it didn't quite overlap, but we have these graphics and it's kind of a lot to draw those. So there's something I really like. So look up the reference material on that. SVG with W3 schools. So right here on the official reference material for all things internet. This is they do a quick example. We've seen both of these. We looked at XML the other day. That's where we make it. Usually, if we're transferring data, we make up the tags. We'll see it in different places. It talks about it. And somewhere down, oh, here it is. In creating them, it said it can be created with a text editor, but it's more convenient to use drawing software like Inkscape. Inkscape is the open source alternative, a very popular open source alternative to Illustrator, I think. Yes, Illustrator. I had to think through all the Adobe products again. Adobe Illustrator is very, very expensive. This Inkscape is a free open source alternative. The one thing it's missing is it doesn't have CMYK colors, cyan, magenta, yellow, and either clear or black, depending on type of printer. Sometimes it's black ink, sometimes it's K, but sometimes it's black and sometimes it's clear, so that when the laser burns the paper, it doesn't change from the burning. Depending on the type of printer, but those are the printing colors. So this one doesn't print as clearly as that. You still get a nice print, right? You have print, it's gonna come out clearly, but you can't prepare the versions. A very popular one, if I start that here and do a quick example, Inkscape. And this is part of the reason I wanted to show you software like this. You might want to make some of it like this one day, or it's open source. A lot of people just immediately think about free when they say open source, but y'all are software developers, right? Open source means we get the source code. We don't get just the installer, we get the source code, and we can do with that source code whatever we want. We can add things to it, we can take things away, customize it to perfectly fit our needs. That's another thing that might show up with your software development careers. You don't have to start from scratch every time. Go grab some open source software and customize it to what you want to do. There's a lot of work available in that, because just about every business could use that. But this has all the buttons, and this is what you would do. So like to draw a circle, we drag our mouse around and draw a circle. And that's what you would, you build software, I would show, because you might build software like this one. A lot of people in graphics interesting. You might get frustrated with some common ones and decide you want to make your own. Make the one that's exactly what you want, because you can never find the buttons, because whoever put those buttons on the GUI apparently thinks very differently than you do. So you want one with the different buttons. And while working in it, the scalable vector graphics, I guess we can make this match like the one we did. Give it I think it was yellow fill. I'm not picking yellow. A yellow fill and a blue outline. And then I'm gonna turn it blue. A3, that's blue. And just draw a circle by dragging a mouse around. But what we do as programmers is we monitor the events and wait for a mouse click to happen. And when a couple of mouse clicks happen, I'll do a rectangle one. So if I go to rectangle, we'd write code that listens for that first click, pays attention to the drag, and then listens for the release. And then that program would automatically go write an SVG tag for that. And then when they come over here and click on the buttons, so like, think that green with a red line out around it. E3. Oh, yeah, I went the other way. 00 D3. So again, hexadecimal colors. And maybe make it really wide. I don't know why that's showing in millimeters. It's not really green, but we might write software that would do that at some point. If I save that, drawing.svg, that'll work. Most of it is just an SVG file, but if I go to open it with a text editor, things kind of like what we saw, a width and height on an SVG tag, that markup language. I apparently picked an ellipse instead of a circle. There's a list of shapes we know. We saw polygons the other day. That's in there, obviously. Then the rectangle, that's a lot like one we did. It looks like they just used the CSS style tag. So hopefully you can look at style attributes. Hopefully you can look at that and figure out pretty quick that we can use this external CSS style sheet for it. We just have to go look up which words it wants and how to write them. But you'll notice stroke dash width, stroke dash opacity. It should look like the regular CSS properties. Just going and looking up that list of them. They added a G tag in for a set of graphics. In software, there's other ones. So this one I use a lot. I turn on my little pen here. This is where I actually use the pen most often. Just do completely freehand drawings and normal pen thing. We're trying to fill. Oh, I have to select it. Select that thing and no fill. And we can get back to any particular one. I grab this and move that completely in front of that circle. I can still drop that to the bottom. Under objects, lower to bottom. Thought it was there. Object. There we go. And still get back to the circle. So when you're making the software, if you're going to make software that's going to be editing graphics, you're going to use SVG so that you can still access every single point along the way. So like that pen, when it just has a timer running, it just takes another, instead of the mouse click once and then another mouse click later, it takes a mouse click every couple milliseconds. If I turned on all the dots, over this one, turn on all the dots, you can see there's a whole lot of measurements taken as that pen moved around. It's basically, I'm going to point that out. You might write software that would do that. So you would write that, and then when you're finished editing the picture, then there's going to be like an export button to export it as a PNG or a JPEG or an SVG when you no longer need access to every single shape individually for editing. Let me save this and look at those. Okay, cool. It did add them. And these are just, those things I added are just paths. What I did with the bandit. We also have a path shape. And a path, so I remember in an algebra class somewhere along the way, y equals mx plus b, how we define a line with a slope and the y-intercept. So we have a slope, or well, really this is the starting point. We use that. So we have two numbers, starting point, another point. There's two different ways it's done. This one has an M here, so I think this is the slope intercept point. So it shows the slope, comma, y-intercept, slope, comma, y-intercept for every single line. But we can also do point to point. First start point, and the second point, third point, fourth point. The XY from each point. Maybe that is start, and then the list of points. Then we go here, then we go here, then we go here, and just spell out all of those. You're probably not going to type that, but there's a good chance you might make some graphic software where you would want to do that. So you might want to be familiar with SVG. It's an important thing. And earlier we were talking about game dev stuff a little. I think that was before class. Scalable vector graphics are nice. We never lose clarity as we scale up or down, go to different screen sizes. It's recalculated every time on the fly. And we just saw it opens in a browser. We could import that other one in an image tag. Image source equals drawing .svg. I can bring that other picture right in there. It's behind, it fell behind that. So, maybe I should add line breaks in there or something. Maybe, or, yeah, I'll just do a break tag. Couple breaks. I also just put this in a paragraph. Can't seem to type correctly. Someone has spread those out. There we go. We got both images. Oh, I already closed Inkscape. You remember seeing the little white box on Inkscape before I closed it? It takes forever to open it, so I don't want to open it back up. That white box showed what was the actual image, and I drew outside of that box, and that's why the rest of that's not showing. So I guess it was showing there. Don't really need these parts. So if you're going to use those graphics, you probably drag the mouse around. We can write it in code, but what you're most likely going to do is write a GUI application where a user drags, where an artist drags their mouse around, and then you write the SVG code, scalable vector graphics, and after they finish all the editing, because then you have full control over it all the way to the end, they can just export that final picture. I'm gonna put breaks in here. And since we're talking about these, I can at least point out something quick with 800 equals 400. That's pretty good. Oh, we do need an ID equals 0. We also have this element called canvas, which is just a surface we can draw on with JavaScript. This is, remember, I make a game engine to create a game and plan on it being on the web. This is the starting point I use. I guess we need to put a script here. I'll just put it in the same file. Script, in the script. And we need some sort of function. Function draw. We'll just do a very quick example. So there's a couple things we need. There are libraries built we can include in here, but from the code, we only have very, very basic drawing functionality. First thing we have to get a reference to this. So scene for a variable name, and like we saw before in JavaScript, document.get element ID. I want to grab that can 0. That's just how I always name them, because there might be several canvas elements. Then we need a way to adjust it. I'm going to call it sketch. Those are just the 2 words I've started using over the years that made sense in my mind. The variable names, whatever you want to call it. You call it canvas, and context would be the actual thing. So then I'm going to use that canvas element we grabbed, and I want to get context. In particular, I want to grab 2D context, and that gives us some drawing tools. We can load an image in if we have one. We can go to Microsoft Paint and grab marker. That'll work. Do a really quick image here. Just an arbitrary image to use. So we can draw that, but we have just the fundamental drawing tools from the programming language. So we could say begin path. We'll start drawing something, and sketch dot move to 123, 234. So that's XY coordinates, X going increases as we go to the right, negatives to the left. Y increases as we go down, like the line numbers on a page, and negative is upward. So the opposite of the math class way. I think it's a sketch dot line to, how big did I make that? 800 or 400? 455, 307. Sketch dots. Stroke style. Hmm. Oh. Thank you. This needs to be hexadecimal color, so. A3, B4, 87. That should be kind of orangish. So some of those words we've already seen. You've seen line too, right? So move to, we start at one position, we go to that pixel, then we'll actually draw a line to that other pixel coordinate there, choose a color, and then stroke runs those commands. Line width, and we have all sorts of stuff like that. Gonna make an error somewhere. Oh, oops. Our hexadecimal colors need to be strings here. And it will pass it back to the browser, and the browser will know what to do with the string. Except I don't see it on there, why didn't I? Oh. Well, we have to call that function, don't we? We do it on clicks and stuff. I'll just put it on the body. So, the useful event is on load. So whenever the page loads, I'll move my hands. Do that. So whenever the page loads, I want to call that draw function. Helps to actually run the code we want to run. And you can see we've got that drew a line there. Draw another line. Sketch dot move to 60784. Sketch dot line to 699 701. You get that same purplish color. I guess that's coming up somewhere. It's switching between orange and purple. I thought it was going to be more in orange. So we can draw lines, and you would have to draw a lot of lines to do that. I have a lot of fun doing that. It's very time consuming. But drawing with code or writing loops and things to do that. Put a mark in here. Sketch dot in path, get a new path. Sketch dot stroke style equals. We just read this time something very red. So AB 2323. That should be mostly red. The other basic drawing one we have is an arc. So if we come all the way around, it's a circle. But we don't have to come all the way around the circle. We need similar things. So the starting point, let's say, forget the size I made it, 400 tall. So I'll do 300 over, 250 down. Then we need the radius. So maybe a radius of 30 pixels. And then we need the start and stop point, but it's measured in radians. If you haven't had trigonometry class, that's another way to measure angles, because it includes length. But it's the distance of the radius around the circle. So if you remember way back to your geometry class, the distance all the way around the circle, circumference, is twice as much as the diameter. And the diameter is, or sorry, the circumference is just pi times diameter, and diameter is twice as much as the radius. So to go all the way around the circle is 2 times the radius. 2 times pi times the radius. So if we start at 0, that's like on the horizontal line, and then we come around counterclockwise, or no, this one will give us clockwise, and trig class is counterclockwise. Those who had trigonometry class. This one actually goes clockwise. We start like on a flat plane on the horizontal line, and we go from 0 to some multiple of pi with 2 times pi, so like 6.29 if we round it, 6.28, and then that extra little bit's gonna round up. 0 to 6.29 would come all the way around the circle. So we need a number somewhere in that range. So I'll do like 5, so it's close to 0, and then 4.3, more than halfway around the circle. I'm gonna say that. Oh. Then we have to say stroke. It doesn't actually draw it until we get that stroke command. Oh, I guess it's vertical here. I thought it was the horizontal plane, but one of those two is 0, probably that one. That looks a little closer to straight up. And then we came some distance around. 6.29 would get us all the way around the circle. And this is very, very basic drawing. So if we wanted to fill that in, we'd have to say something like for let I equal R equal 1. Well, R is less than 30. R is going to increment. And we'll just change that radius every time by 1 pixel. So to like fill it in, we have to actually fill it in. I probably should have changed by that. So I'm between pixels, not on pixels. But we can also get really neat patterns that way too. So you can also just set up some randomization in your code and use lines and arcs to come up with neat fill patterns, things like that. It can be a whole lot of fun. We can also draw images. Sketch dot draw. There's an extra step here, but we have to have the image tag up here in order to draw it. So I'm gonna do this. Image source equals smile. That one I just created. Python width. I'm gonna add something extra here, the style. So an inline style rule, and I want to set display to none. Because I don't want to actually show it on the web page. I want to draw it on the canvas. We can draw. Oh, we need an ID for it. Like always, like we saw earlier, we need a way to refer to that. So I'll just give it the ID smile. Then down here, I can say draw smile. It's set to automatically look for an ID. And then where do we want to draw it at? Say 159, 159. The XY coordinates we want to draw it at. I think we can skip the stroke on this one. We might have to come back and add it. Sketch.draw is not a function. Let's draw image. Let's see who recognizes this function. My value is not a type. I don't need the quote marks. I was doing this from memory. Oh, there it goes. It's one of my favorite things to do, but it's not Uh, It's been a couple years since I did that. Let me move that way. It's not in front of our lines and circles. It's maybe 359. 359. There we go. Oh, that's too far. 259. There we go. So if you have an image, and this leads like I keep mentioning, this is the starting point if I'm going to make a game engine. And you're probably thinking about the big, huge game engines that catch all things that fit every possible need you could have. But for those who have worked with game engines, have you ever used every single function in a game engine on a single game? We usually don't need all that. So we can strip it down and create only the parts we need. But we can load an image in and then move it around, run a clock, set up a physics engine so we know where the borders are. That's a different class. But drawing in code can be really fun. It can be time consuming, but I enjoy it. So there's lines and arcs, which eventually become a circle. You'll notice that in that little crossover, it's not drawn. It didn't pick the pin up, so it kind of filled in the circle anyway. But enough pieces there to try drawing a stick man. I would recommend that. This is going to be on the domain host soon, so you can look at it as an example. Load in pictures, and then you need to set up clocks and delays. So if we just told it to move, it would happen quicker than a human could detect it. It would just suddenly be gone before our eyes even glanced at the page. But line circles, load in images, and we can draw right on an element. That's the other way to do animations. We saw CSS animations for the subtle things. If you have a big animation, the full-blown thing you want to do, you want to use the canvas element. And it does also accept WebGL, which is pretty much the standard for 3D graphics across the internet. But that's another course, or you'll want to start looking through documentation, WebGL, if you're interested in that sort of thing. Some stuff on graphics that would probably relate more to other classes, but they do kind of relate to this course. Other places in the software development degree. So we saw a whole lot this semester. Hopefully you feel like you're getting a bit of a good foundation in HTML, CSS. CSS shows up all over the place. As far as HTML, it's kind of like what we were just looking at with SVG. What you'll probably do is make a GUI application where an artist drags their mouse around, and when they click and release the buttons on their mouse, the program you wrote will automatically write that HTML code. And then the artist will put together the CSS to go with it. But we see CSS everywhere. There is a standard in one place. So in pretty much the main GUI package in all of our programming languages, almost always accept CSS. If not, you can probably go to GitHub and find a little extra, something somebody made custom so that it will accept CSS. So that one gets used a lot. This is part of the pathway to do things. There's more classes to come. Hopefully you feel like you got a good foundation for HTML in this class. Does anybody have any questions before we wrap up here? The head shaking no here in the classroom. Okay, I assume the silence means no questions. So I guess that'll be it for the semester. It's an active subject we learn by doing. So a whole bunch of time on our scheduled block still, and from now until 3:50, I'm not going to be doing anything but sitting around waiting for questions. Right? Please use our time productively. I can help with more than just this class. I teach a number of classes, and anybody's looking at the tutoring schedule, you probably saw them on the tutoring schedule for physics and math. I'm actually a math person. Just know a lot about computers. All my highest degrees are in mathematics. But if you look at the tutoring schedule, you see now I can help with physics and math and writing, and sometimes CAD's on there. There's a whole big list of things. I can help with more than just this subject. Please use our time productively. If you have any questions, let me know. Otherwise, y'all have a great spring break, and hope to see you in the future sometime. See ya.